Okay, everyone. So I promised you all I am going to record a video of solving this volleyball problem. So let's get started with that. We have some information given in this problem. So let's go with that. This problem says find the velocity and the direction. That is nothing else. Whenever this object is projected, I will use a different color. When the object is projected, how much is the velocity v and this angle alpha? If someone need angle beta, theta, alpha is just a symbol for this situation. So at the end, we want to find how big is this velocity and how much is this angle alpha. That is the plan. So whenever something is projected, we do have this initial velocity components. We have seen it now. V times cosine angle alpha in the x direction, that is the initial velocity along the x. And this guy, V times sine of the alpha, that is the initial velocity. So this guy, V initial x, this guy right here, let me write it down separately. This is going to be V times sine of the alpha. That is going to be my V initial y. And also, the problem text has some more information. It says it is going to leave the hand by 0.83 meters and it is going to hit the maximum height, that is at 2.43 meters. There we go. That gives us initial y information. Right here, when it starts, y initial is 0.83 meters. Object is going to do a delta y change in y distance. This is y final, that is equal to 2.43 meters. And also, everyone, the court has the net halfway through. That is the idea. It is going to hit the maximum height. So this is the H max location. We all know that right here as the maximum height, V final along the Y direction, or you could say Vy at the maximum height is going to be 0. Not the X. X component is going to be there, that the same component V cosine alpha. This will be the same as V cosine alpha. It is going to stay same constant speed along the Vx. It will be the same. We talked about that. And the X location right here, X initial will be the 0 to at the beginning, but halfway through 18 meters divided by 2, this X final will be 9 meters. And our focus is going to be initial to final, that is the start to H max. We are not worrying about the ball is going to hit in the ground. Our plan is, everyone, we have two unknowns in this problem. Set up two equations to find the unknowns. That is the target. Okay. And to start off, how to set up the equations, how to pick the equations. We do have delta y, that is equal to y final minus y initial. I do have some numbers, 2.43 minus 0.83. That is my delta y. At the same time, I do have delta x, that is this much right here, that is equal to 9 meters. So that gives an idea. We could apply equations along the delta x, delta y, or x and y directions, thinking about the delta y, delta x. Okay, now everyone, let's consider. I am going to try applying my y direction up is positive. That's when the acceleration along the y becomes negative 9.81. Up is positive. Gravitational acceleration is pointing down. Now, When I apply v final y squared, again, I am considering from the beginning to the max height. That is my ending event, h maximum, equals v initial y squared plus 2 times acceleration along the y delta y. At the maximum height, we all know that this is the final velocity 0. My initial y velocity is v times sine of the alpha, square of that, and I do have negative sine 9.81, 2 times 9.81 multiplied by the delta y, that is equal to 2.43 minus 0.83. There we go. And you can move things around. You can move this whole term to the left-hand side. You do have negative sign goes away. 2 times 9.81 multiplied by 2.43 minus 0.83. This whole thing is equal to v times sine alpha, square of that. You can do, take the square root. That way, you have an answer for v sine alpha. And this is the time you are going to use your calculator and plug the numbers. You are going to see how much is that. You will find v sine of the alpha, that is equal to 5.6 meters per second. We found one connection along the y direction. Okay, so we are going to consider the same thing along the x direction for the next one. And all we are going to do, since I have the delta x, can I apply the equation along the x direction? So you have this on the record. I'm going to erase this to have this information for me to apply this equation, okay? So what we found, I am going to summarize right here so far. V times sine alpha, we found it as 5.6 as a result of the previous step. I do have that guy ready now. When I apply along the x direction positive right here, I do have delta x equals v initial x time 1/2 acceleration along the x time square. You have seen it multiple times. This is going to get to a 0. The reason acceleration along the x is 0. And we do have delta x, that is 9 meters, equal initial x component of the velocity v times the cosine alpha. Okay, everyone. Now we are going to get stuck. How much is the time? If I had a way to find the time, I could get same as here. I could have an equation v cosine alpha equals what? Then math is much easier. That is the systems of equations we were talking about. So let's go the next step. In order to get the time, there's no way I can keep using the x direction. Instead, let's try one time. Up to the maximum height from the very beginning, let's consider I am going to apply v final equals v initial plus acceleration time. Again, in the y direction, y direction, y direction. At the maximum height velocity 0 along the y direction equals, this is going to be v times, let me take a little more space. This guy be 0 equals v sine of the alpha, that is the initial y component of the velocity, negative 9.81 multiplied by the time. I do have Bring this guy to the left-hand side. 9.81 multiplied by the time equals V sine alpha. Did we get it earlier? Yes, we do know V sine alpha is 5.6. So it is a matter of rewriting this one. Let me write it this, everyone. You do have this guy 5.6. To get the time, when you rewrite this one, time will be 5.6 divided by 9.81. You get the time to be. Do the math, do the calculator. You will get time equals almost 0.57 seconds. Okay, so I'm going to rewrite this back here. We do have V times sine of the alpha and plug the time answer right here, 0.57. I do have 9 divided by 0.57. That is equal to V times cosine of the alpha and V times cosine of the alpha. We will get the answer when you do the math step, 15.78. That is equal to V times cosine alpha. There we go. What we need along the X direction, along the Y direction, we have these two guys. Okay, so you can check these back, play back what we did. You can go back and forth again and again to get these stuff. Now, everyone, I'm going to rewrite this guy right here. V cosine alpha, that is equal to 15.78 meters per second. Now I'm going to erase these. You have a record in the video. Now we are going to solve these systems of equations. I do have, there's multiple ways to do that. I am going to show one way. V times sine of the alpha, that is equal. This is my first equation. Let me call it that way. This is my second equation. I am just to inform, this is my equation number 1, equation number 2. I am going to do divide these two equations. I am going to do 1 divided by the 2. There's more than one way. I showed you in the class today. There's more than one way to do it. And I do that left-hand sides divide, right-hand side divide. So I do have V times sine alpha divided by V times cosine alpha equals 5.6 divided by 15.78. Now, just a matter of, again, grabbing the calculators. That's where we are heading. And we do have V is going to cancel out sine alpha divided by cosine alpha, tangential alpha. This is 5.6 divided by 15.78. Please double check the math. And you will get alpha equals tangential inverse 5.6 divided by 15.78. And when you do the math, get the calculator, crank the numbers, you may get something closer to, oops, my bad, everyone. You may get something closer to alpha is equal to 19.6 degrees. That is the angle alpha. Once you have the alpha, you can either go back to equation number 1 or number 2 to plug, find V equals what. So I'm going to erase this one, and if you go to equation number 1, you have V times sine of the alpha equals 5.6. V equals 5.6 divided by sine of the alpha angle 19.6 degrees. you will get V number equals to something around 16.7 meters per second. Problem is asking how much is the V? There we go. We have the V number. How much is the angle? There we go. We have it. And also, everyone, this is one way of doing that. Also, as I mentioned earlier, inside the classroom, you could go solve this problem using this relationship. Sine squared alpha plus cosine squared alpha equals 1. You can subject for sine squared alpha. That way, the substitution is going to be here 5.6 divided by V and square of that plus cosine alpha, this guy, 15.78 divided by V, square of that equals 1. Then you have to work through the math. V equals what? Only one unknown in the equation. Once you have the V, you can go back to them, find the V. So systems of equations, whenever we have two unknowns, we set up equations, two of them minimum, find the unknowns, maybe substitutions, maybe dividing, and we can get up to, there's more than one way to do this one. There's another way. I will stop after saying that one. You do have V sine alpha equals 5.6. You can subject for V from this guy, 5.6 divided by sine alpha. This is the third way. You can substitute this V for this guy right here in that other equation. So you do have in the equation number 2, when you substitute for the V, you have 5.6 divided by sine alpha. That's the V. The rest is remaining. This is cosine alpha. That is 15.78. Again, you get tangential, cotangential alpha relationship. Still, you can solve this, everyone. So this is a tool, strategy, systems of equation. I am really looking forward to third midterm type of material. But for now, it is good to have. So please practice, everyone. You all can do this. And please talk to me if you need any help. Bye-bye, everyone.